Hello everybody, this will be a video covering the Honors Pre-Calculus, Chapter 13, Section 2 questions. First item on the agenda. Thank you for your feedback, those of you that are letting me know about stuff. Thank you for sending me your questions. Thank you for the work you're doing. You guys seem like you're keeping on top of it, and that's just, it's astounding. It's amazing. Um, I'm going to keep putting forth the effort as long as you guys do. That's not a reason, Pierce, to start some kind of revolt, revolution, organize something. So, no. All right, let's try this. For number 15, it said something about, I don't know, evaluate the limit if it exists. Give you some hope there that all of these are going to be DNE, doesn't it? Yeah, don't hold your breath. All right, so for the numerator, look at that. It's the difference of perfect squares. I'm sorry, I'm going to be lazy on this one. You really should write the limit as t approaches -3 over and over and over and over and over again. I'm just going to try and simplify the algebra part of it. T plus 3 times t minus 3. I hate using t as a variable because it's got to be some sort of italicized. All right, then let's see. 2t squared. The only way to break that down is 2t and 1t. Last term is positive, so my factors use the same operation. Look to that middle term, that uses addition, so both of these use addition. Factors of 3 are going to be 3 and 1. So if I check that really quickly, outside product gives me 6t, inside product 1t, 7t, there it is. Okay, and then lo and behold, we can see that we have common factors, reduce that down. So now we can say it's the limit as t approaches -3 of t minus 3 over 2t plus 1. Now we've simplified it a step there. I don't know whether you checked. If you tried to do direct substitution here at the very start, you got a denominator of 0. That's bad. That's very bad. If we try direct substitution now, do we get a denominator of 0 anymore? No, no we don't. Let's do it. -3 minus 3, I believe, is -6. -3 times 2 is -6. -6 plus 1 should be -5. The limit of this function as t approaches -3 is 6/5. That's it. As soon as we can get it to a point where our denominator is not a 0 anymore, we can use direct substitution. Number 7. That looks kind of mean. Oh, look. If we put in 0 in place of h, we get a denominator of 0. That's not good. So let's deal with the algebra. Okay. So if I take 2 plus h cubed, oh, wasn't that so convenient that we went through the binomial theorem last chapter. So we know this should turn out to be 8 plus 12h plus 6h squared plus h cubed. In my numerator, I still have the -8, and it's all over h. Well, lo and behold, rearranging terms here, I now have 6, let's start with the highest degree, shall we, Mr. Mark? What a good idea. 6h squared plus 12h all over h. Oh, and in our numerator, we have a common factor of h that we can take out. So that gives us h squared plus 6h plus 12. reduce the common factors. So now we're looking at the limit as h approaches 0 of h squared plus 6h plus 12. Do we get a denominator of 0? No, we don't have any denominators anymore. We can do direct substitution, so this will be 0 plus 6 times 0 plus 12, which hopefully we can see is 12. So the limit as h approaches 0 of this funky looking thing is 12. Now, for those of you that have really, really good memories, I warned you about this. There was one of the problems back in chapter 12 where it had this strange kind of a what are you doing with the h cubed, or I think it was cubed, all over h kind of a thing, because that was setting you up here. And again, this goes even deeper. Okay, it goes, limits are basically the start of using that basic form of a function, and you will learn more about that next year, not right now, because we're going on to number 19. Ooh, 19. You guys don't like the square roots, I'm guessing. I'm guessing that's where we... Oh, you're not going to be happy about this, but you can do it. I've seen you do it. You can do it. Conjugate. Ooh, he said that. He said that word again. The conjugate of square root of x plus 2 minus 3 would be square root of x plus 2 plus 3. And yes, we are going to make an absolute mess. Now, in my numerator, I am just going to leave that. No. Oh, I like this song. I'm sorry, the denominator that turns into a mess right now, I'm going to leave that in its factored form. As ugly as it is. If you can't hear, it's called Friendship by Chris Stapleton. And that's pretty cool. All right, now the reason that we're going to multiply by a conjugate there is, yay, get rid of Mr. Square Roots. Okay, so FOIL the numerator. Square root of x plus 2 times square root of x plus 2 will hopefully give us x plus 2. We're multiplying by the conjugate, so that outside 3 square root of x plus 2, the inside product negative 3 x square root of x plus 2. Those cancel, and then we take last term times last term. Negative 3 times positive 3 is minus 9. And hopefully you see the benefit here of leaving that denominator in its factored form. We can make them look exactly the same and reduce. So this really means we're looking for the limit as x approaches 7 of, oh, we've eliminated everything from the numerator, so it's just the implied 1 over square root of x plus 2 plus 3. Now, that whole do we get a denominator of 0 thing again, if we now try and substitute 7 in place of x, let's see here, 7 plus 2, that'd be 9. Square root of 9 is 3 plus 3. Oh, look at that. That's 1 over 6. Definitely not a denominator of 0. We can do the direct substitution. There it is. Now, it wasn't pretty for a couple of steps, but that's okay. Hopefully you've got somewhat of a perspective to how good your memory here. Things that start off this way that, geez, it's messy. And then Mr. Mark says, oh, let's multiply with a conjugate. That sounds like a good idea. Oh, and it gets worse because it's going to make it better. I mean, they've written the problem that way. Okay? They've written the problem that way so that you're going to get common factors. You're going to be able to reduce this, and it'll be fine. All right. For the next part here, find the limit and use a graphing device to confirm your results. Okay, so for the first part, we're going to use, again, our lovely, oh, look at that, the numerator as, again, the difference of squares. So we can factor that down into x plus 1 times x minus 1. And our denominator, here we go again. X minus 1, sorry, square root of x minus 1. Let's multiply by the conjugate. Square root of x plus 1. And yes, Kate, that's what we're going to do just about every time that you see a square root is, yeah, let's think about multiplying by that conjugate. So square root of x plus 1. I know it's messy, but that's all right. X plus 1, x minus 1, square root of x plus 1, all over. Now, if we take square root of x minus 1 times square root of x plus 1, square root of x times square root of x, it gives us x. Outside, inside products cancel. That's why we do the conjugate. Negative 1 times positive 1 is negative 1, as advertised. Look at that. So now what we're looking for here is the limit as x approaches 1 of x plus 1 times square root of x plus 1 over, well, our denominator now is 1. There's no chance of substituting and getting a denominator of 0. Our denominator has to be a 1. Let's do the substitution thing. So x plus 1, if x is 1, that's 1 plus 1, so that's 2. And then we have square root of 1, which is 1, plus 1, that's 2. The limit as x approaches 1 for this function should be 4. No, it shouldn't. It should be 4. To the calculator. So again, numerator and denominator is kind of funky. So I just put everything in the numerator in one set of parentheses, denominator, another set of parentheses. Again, be careful about when you're using that square root about what's underneath the square root and using that right tab button there to get out of the square root. Well, isn't that just absolutely lovely looking? Again, we're saying that it approaches 4 as x approaches 1. And then again, we lose. Hey, how about we just trace it? And again, if you'll notice here down in the bottom right corner, approximates the coordinates for that particular pixel. 0.5, 0.6, okay, getting closer and closer. Oh yeah, it's undefined, but 3.7 on this side, 4.3 on the other side. Yeah, looks like 4 is a good answer. Okay, on to 25. Again, if you try and substitute negative 1 in our denominator, you're going to get 0. That's bad. All right, so factoring. Factoring is your friend. So we'll take x and x. It's x squared. The negative sign on the 2 tells me my factors have to use opposite functions. Factors of 2 are, let's see, 1 and 2. Outside product gives me negative 2x, inside product positive 1x, so that works. In my denominator, I have a common factor of x, so that gives me x squared minus, hey wait, x squared minus 1, we can take that down even further. x plus 1 times x minus 1. Quelle surprise. Look at that. We can reduce it down. So this is now the limit as x approaches negative 1 of x minus 2 over, now who cares about the numerator? Our question is the denominator, x minus 1. So if we substitute now inside this set of parentheses here, we're going to get negative 1 minus 1. That's negative 2. Hey, we don't get a 0 anymore. So let's do the substitution. Negative 1 minus 2 in the numerator is negative 3. In my denominator, I'll get negative 1 times, I just talked you through that, negative 2. So this is negative 3 halves. Looks pretty good to me. Ooh, that's a interesting function we got there. On the left, it looks like the x-axis might be an asymptote, but on the right, oh, it definitely crosses. Yeah, big deal. We were looking for the limit as x approaches negative 1. Where are we here? Oh, well, we can go from this way. Negative 1.49, negative 1.7, I guess it's undefined. Negative 1.34. We were estimating negative 1.5, negative 1.5. Yep, negative 1.7 on this side, negative 1.34 on that side, negative 1.5 is in between. 27 was a really popular one. Gee, can't imagine why with a square root in the denominator. What? All right, so for part A, they wanted you to graph that beast and then come up with an estimate of the value. Yeah, whatever. I'm presuming that you guys are okay with part B, making a table of values. So yeah, we could put in some negative numbers. 0.6122, 0.66163, 0.6617. And we can put in some positive numbers there. I would surmise, again, from the right, from the left, it's looking like it's headed towards something like 0.66666. So in other words, 2/3. Yeah, let's put that to the algebraic test, shall we? Oh, yes, we've got that whole square root, two separate terms in the denominator. Forget about the fact that there's two square roots underneath the radical. Two terms in the denominator. Yeah, you knew this was coming. Didn't like it, but you knew it was coming. So square root of 1 plus 3x plus 1 over, well, same thing. Square root of 1 plus 3x. Now don't let that non-traditional order fool you there. Leave that numerator in its not pretty factored form. And we're multiplying by the conjugate so we can get rid of the radical stuffs. Again, square root of 1 plus 3x times square root of 1 plus 3x should give me 1 plus 3x. Outside product and inside product will cancel. Negative 1 times 1, that would be negative 1. Oh, wasn't that interesting? The constants cancel here. Over 3x. And we can further reduce that by removing just those variables. Okay, so now the limit as no, x approaches 0 of 1 plus 3x plus 1 over 3. Now our denominator is a nice constant, and it's not a 0, so we can proceed here. Just do direct substitution. We put in 0 in place of x. 1 plus 3 times 0, that's 1 plus 0, that's 1. Square root of 1 is 1. 1 plus 1 is 2. Our denominator is 3. Hey, would you look at that? That number sounds familiar. That's what we got from the estimate of the chart. And again, 27 was a frequently requested problem here. God, I sound like I'm a DJ or something. Because, yeah, square roots, conjugates, they're so much fun. All right, and we're going to wrap this up here with number 31. Just when you think you got used to things, just when you thought, yeah, okay, this is making more sense, then they throw an absolute value at you. Now, again, hopefully you remember the whole absolute value graph. If you look at one side of it, it looks just like a nice line. If you look at the other side of it, it looks like a line. But they're not the same line. So what you will usually need to do with an absolute value function is split it up and look at it from the standpoint of a left-handed and a right-handed limit. Let's do those individually and see if they converge or not. Okay? So we want to look at, first of all, the limit as x approaches 2 from the left. No, it's not that. It's just a negative sign. Then we'll look at the limit as x approaches 2 from the right. Now, if you think about the left side of our standard absolute value function, that's the negative part of it. Well, so this is the negative of x minus 2. Now again, if we do substitution, yeah, this gives us a denominator of 0. That's not a good thing. But you'll notice here, oh, would you look at this? Boom, boom, boom. So this becomes the limit as x approaches 2 from the left of negative 1 over 1. That limit should be negative 1. Let's see what happens here as we approach 2 from the right. So on the right-hand side of our absolute value function, all of those x minus 2 functions are positive. Well, okay, very much similar to what happened over here. The limit as x approaches 2 from the right is 1 over 1, which is 1. And again, over here we have negative 1, and over here we've got, oops, not the same thing. This limit does not exist. Okay? So again, just to recap that one, anytime that you've got an absolute value function, you need to split it up and find the right-handed limit, find the left-handed limit. If they converge, great, you found your limit. What will happen here frequently, I won't say all the time, but frequently, the left and right sides are not going to match up. So the limit does not exist. Okay, so again, that's our TLA for this chapter. All right, that pretty much wraps it up. Thanks for listening. I miss you guys, and I don't want to get your hopes up too much here, but I'm hoping to maybe post a video of the doggo soon. See you later. Bye.